Hi, I'm Vidita. To run this, first we have to import all the libraries that are needed. For example, NumPy, Pandas, Matplotlib library, and also Seaborn. Next, we have to upload the dataset that is used. So in this case, we have uploaded cancer.csv and we have also run it. This is retrieved from Kaggle. To show the first few lines from the dataset, the function data.head is used. Data.shape, when we run it, the output is 569 and 33. This means this dataset has 569 rows and 33 columns. The next function is data.info. So this shows the attributes that are used in this dataset. The next function, data.head 30. The output of this shows the first 30 rows of out of 569 rows from the dataset we have uploaded.
Hi, my name is Krista, and I'll be talking about the observation of the data column, which the column that is going to be predicted is the diagnosis column. So then we have implemented data cleaning by removing some of the corrupted and incomplete data. For example, the only column that has different data type, which is the ID column that will be dropped. Then the values in diagnosis is replaced to moving on to the exploratory data analysis is to visualize the columns that the correlation map was done to show the correlation between um, each other columns. So in order to conduct our analysis easily, we have converted the target column as melatonin equals to 1 and P9 0. So lastly, this is the bar graph that represents the correlation with target.
Okay, now I would like to present about the train test split. And here is our X and Y. The X and Y value has been determined to build the predictive model. Standard scalar and train test split instances has been called. Then we have print out the first 10 rows of our dataset. Then we have print out the train test split result. So this is the result. We have determined the result by using the X and Y which we determined earlier. So then we have used the k-neighbor classifiers. Basically, we use it to predict the type of the cancer using the feature. So then we have determined the test score and the train score. So basically, the test score and train score has been determined. And once we determine it, we have created a table, which is at here. And what the table is based on train score versus test score to observe the relationship between the two values.
Okay. Next up, we are going to build the k-neighbor classifier model. So as you can see, the KNN model classifier is and then the X and X train and Y train values have been fitted into the model. Then the train score and the test score of the KNN model is printed. So if we run this, you can see the train score of our model is 1, whereas the test score of our model that we built is 0.9. Then moving on, we're going to look at the prediction values. So for this, we are going to use the confusion matrix. So we use the Y prediction. We are going to predict the Y values using the KNN predict using the X stacks. Then we call the confusion matrix using the Y test and Y prediction values. So as we run this, you can see there is a confusion matrix table has been built with all the predicted data. Then finally, to calculate the accuracy of the KNN model that we built, we are going to import the random forest model using the sklearn ensemble and importing random forest classifier. Then we're also creating a Gaussian classifier with the n estimators of 100. Then we train the model using training sets, which is the Y prediction. Finally, we're importing metrics from sklearn to predict the accuracy of the model. So we run this first. Then for the accuracy, you can see that our model produces an accuracy of 0.96, which is around 96%. So that's all for our code. Thank you.